Today's lesson's over section 2.2, the limit of a function. Now, the formal definition of a limit is given a function f of x, we say that the limit of that function as x approaches a value, we call it a, will equal a value we call L. Now, L is actually the y value of the function that we are approaching on the line. So it's an arbitrary, like we're going to get arbitrarily close to that limit of L as we go or we are moving from left and to right to get to that value. So as you can see from the graph, we're looking to approach the x value of 2, and it looks like from both directions we're heading and we're getting towards the y value of 4 for the limit of x squared as we approach 2. Now let's take a moment and look at some different scenarios that could happen with this. So looking at the top, I have different graphical examples of kind of basically the same problem, but with just different tweaks to them. So the first one, the graph is moving from left to right. It looks like we're approaching 2 for the function of f of x. And notice that the y value at that spot is 1. So we get to say that the limit is 1. The second one, we're looking at that. We're still approaching this value of 1, but notice that it's an open circle. So regardless of the open circle and it not being equal to 1 there, the limit is not concerned with whether it is actually defined at that point. It just cares about approaching that value. So from the left and the right, is the function heading towards 1, then it's the same. So then it's still a limit of 1. Same thing with the third one all the way to the right. We're still approaching that same value of 1, regardless that it's defined as something else below. You can see the dot below the open circle at that point, which still makes it a function, but it's still approaching that 1. It's not approaching that dot. So our limit is still 1 as x approaches 2 there. So now if we're able to take a look at the numerical examples, we can plug in -1 into both top and bottom of this one. And so you'll notice that on the top we get 0, which is fine on its own, but in the denominator that negative gets canceled out to make it +1, which makes it 0 as well. So here we would say this is undefined at this moment. This is something called indeterminate form, which we'll talk about later down the road. But for right now, we're just going to describe this as undefined. But if we go to the graph, even though it's undefined at that point, your graph is from both sides approaching a value of -1/2 from both sides. So then we would say the limit is -1/2 rather than saying it's just undefined based on that graph value. So sometimes you have to go to the graph to kind of check that out. The same thing kind of happens with the limit of sine of x divided by x as x approaches 0. When we plug in 0 top and bottom, here on the bottom, obviously it's 0, so it's already undefined, but on top it's 1. So we would say it's undefined, but when we look at the graph actually approaches the value of 1 on the top. So then that's what we would say that the limit is for this problem. So sometimes the limit that we do get doesn't correlate with actually what the limit is. So we'll always kind of have to double check with our graph calculator. So here let's try some of these examples. So example 1, here we're looking at point A. It does not exist because you don't have the limit coming from both sides. So since it's closed off on the left side, there's nothing going there, so we have to say it's undefined for that one. For B is the same thing. Here both things are not approaching at the same spot. For C, that's the vertical y-axis, so we are approaching the value of 5 up there, so we'd say it's 5. At D, it does not exist because there's no connection there. They're not approaching the same value. For E, it would be 2. Even though it's open circle and it's defined below, we're still both approaching 2 from both sides. F, it's 3 because we're approaching pretty easily there. And for letter G, it would be does not exist as well because you don't have the limit, or the function is not approaching from the right side, only for the left. Now sometimes we're going to give you problems where we have you graph or sketch a graph based on what the limits are and what some of the functions are notated as. So here it says the limit of f of x is equal to 2 as x approaches 0. Limit of f of x is equal to 0 as x approaches 4. And then f of 0 is 2 and f of 4 is 1. So here I plotted both those points. So f of 0 is 2, that's just an ordered pair, 0, 2. And then 4, 1 is over there on the right. Now, here, if you look at the limit of f of x at 4, from both sides, we're approaching the value of 0. So there's a skip there. Now, for the other one, a limit of f of x as we approach 2 is the same as f of 0 is equal to 2. So because those two are the same, we can actually just graph our line all the way through. And so since we're approaching the y value of 0 at 4, that means we have to connect to the open circle rather than the other one. And notice that there could be multiple answers here, so don't feel like it has to be exactly the same, but the points and the open circle wouldn't be necessary for it to be correct. But then everything else, how the graph goes, is kind of still up to you a little bit. So there are multiple answers for that one. Now here we can also have limits of one-sided functions. So let there be a function f. If I look from the negative side, so the left side of a, that means we could have a left-handed limit. And so in those cases where we had a and g where there's only one side of the function, if we were looking from the right side of a, there could be a limit there, but it's just not a limit from both sides. So the limit on its own is from the left and the right together, but you can also look at them separately. So notice that the statement on the bottom there, if we have a limit, that means that both sides are going to the same thing. So here, let's look at some left and right side limits. If I'm looking at the left side of -3, that one is approaching 0 for a y value. For letter B, we're looking at the right side of -3, so notice it's different. So it's -2, it's going down. For just -3 as a whole, because they don't match, that means it does not exist. So there is no limit there. For letter D, the right side of -1, we're going down, we're going to -2. Then from just negative, or the left side of 2, that one is going to -1. And from the right side of 2, that one is going to 2. So here you notice that we can have several different ones, but you'll have to keep in mind when they're looking on one side or the other, or collectively both sides at the same time. So keep those things in mind when you're doing this, okay? Have fun.